Hey guys, here's part two of the lesson for 8.5. What do you do when you have a rational inequality? When you have a rational inequality, you have to think of two possibilities. Either our denominator is positive or our denominator is negative. So basically, we're going to have to solve this. I've got a rational here, 8 over x plus 5 less than or equal to 4. I'm going to have to solve it twice. Let's assume it's positive over here, and we'll assume it's negative over here. So here, if I got 8 over x plus 5 less than or equal to 4, I'm going to multiply both sides by x plus 5. And if it's positive, then I'm just going to get 8 is less than or equal to 4x plus 20. I'll subtract 20. So I get negative 12 is less than or equal to 4x. Divide by 4. And I get x is greater than or equal to negative 3. And of course, the reason why it's reversed like that is because I just wrote it with the variable on the left-hand side. Now, part two of this is, okay, my denominator is positive, so x plus 5 has to be greater than 0. And if that's the case, whoops, if I said, well, I don't need that. If I subtract 5 from each side, I get x has to be greater than negative 5. Now, in order for this part to be true, it's got to satisfy both. So what values are both greater than negative 5 and greater than negative 3? It's these, right? Any number that's greater than negative 3 will also be greater than negative 5. But there are a couple of numbers that would be less than negative 3 but greater than negative 5, so those don't count. All right, so now if it's negative, I have my 8 over x plus 5, it's less than or equal to 4. When I multiply the top and the bottom by my numerator, or my denominator, I'm going to get 8 is greater than or equal to 4x plus 20. Because remember, if x plus 5 is negative, you have to reverse the inequality. So subtract 20 again. It's really, you're just doing the exact same thing. I get negative 12 greater than or equal to 4x. Divide by 4. I'm going to get x is less than or equal to negative 3. And then I also have to consider, all right, so if x plus 5 is less than 0, and I subtract 5, I'm going to get x is less than negative 5. So which numbers are less than negative 3? Again, which ones are both less than negative 3 and less than negative 5? It would be these guys here. So then your solution is going to look like this. You're going to say x has to be greater than or equal to negative 3, or x has to be less than negative 5. Both of those in combination give you the answer. Now, if you look in the textbook, there's also a way you can do this using a graphic calculator, where I would graph my original you'd graph this guy as y1, graph that guy as y2, and then you have to look to see where your errors are. It's probably less work, but at the same time, a lot of you don't have a graphic calculator at home, and it's a little bit harder to interpret your answers. I think if you just do it algebraically, it's fine. I mean, it does seem like a lot of work here. I'm having to do both a positive and a negative case, but the math, I think you guys will all agree is pretty much the same. The only thing different here is where my inequalities are pointing, right? And then I have to consider which cases make sense at the end, and I'm going to put those answers together. So this is what solving inequalities is like. I know I didn't put that in the last video, but my little writing tablet battery started dying on me, so I had to recharge. Anyway, here it is, and hopefully this will help. You're going to have do some more work on this on Wednesday, and if you're in cohort A, you're going to start this Wednesday if you're cohort B, and I will be available to answer any of your questions, either in person or online. Just let me know.